Hello everybody, welcome into another lesson. So today we are going to start talking about inverse properties of composition of trig functions. So as you know, if you take the composition of a function and its inverse function, you should get back what's inside. So in general, we know if we take f composition of f inverse of x, you should just get x, right? And likewise, if I take f inverse composition of f of x, I should also get x, right? So I should get back whatever's inside. Well, the same principle applies here to inverse trig functions. So provided that everything, that what's inside is within the domain of the function, I'll get back what's inside. So if I take sine inverse of the sine of x, if it's within the domain of the sine, I should get back x. And then on the flip side, sine of the sine inverse of x, if that x is within the domain of the sine inverse function, I should just get back x. And likewise with your inverse cosines and inverse tangents and tangents. So let's do some problems here to illustrate this. And let me set up some triangles again here. They are going to come in handy. Alright, so let's see. We'll do a 30, 60, 90 triangle for sure. So you got 1 square root of 3 and then 2. Let's also do a 45, 45, 90 triangle. So we'll do a 45, 45, 90 triangle in addition to that. So 1, 1, square root of 2. Alright, so there's all the triangles. Now let's see what we got here. So we're going to have sine of the arc sine of 0.7. So we have sine of the arc sine of 0.7. Well, the domain of the arc sine is from -1 to +1, so that 0.7 is within the domain of arc sine. If I take the sine of that arc sine, I should literally just get 0.7. That should be my answer. I should literally just get 0.7. Now, if I take the tangent of the arc tangent of 35, well, what's the domain of the arctangent function? It's all real numbers, right? So it's within the domain, so the tangent of the arctangent of 35 would just give me 35. So 35 should end up being my answer. Alright. How about cosine of the arc cosine of -0.3. Alright, so cosine of the arc cosine of -0.3. Well, what's the domain of the arc cosine function? -1 to +1. This is definitely within the domain, so that is just going to give me an answer of -0.3. And I promise you they don't stay these simple for this lesson. It'll get a little bit tougher. And you're also going to see why the triangles are going to come into play relatively shortly. And then you have sine of the arc sine of -0.1. Alright, so sine of the arc sine of -0.1. Well, what is the domain of the arc sine? It's -1 to +1, so we're well within the domain of the arc sine. So I should literally just get -0.1 for my answer. Alright, now here's where it's going to shift a little bit. What if I had arc sine of the sine of 3 pi? Arc sine of the sine of 3 pi. And if you go to take the composition, it would look like you're just going to get 3 pi. However, here's the thing. 3 pi is not within the domain of the arc sine, is it? Arc sine is -pi/2 to pi/2. If you're in a situation like this, you might think then you can't solve this, but you can. What is the sine of 3 pi? That's 0, right? The sine of 3 pi is 0, so this would literally just turn into the arc sine of 0. Now, what's the arc sine of 0? It's literally going to be 0, right? You would get 0 degrees. So 0 degrees or 0 radians, however you would like to list it, you would get 0 degrees or 0 radians. So sometimes you have to be a bit creative and know what your reference angles are. Now, what about the arc cosine of the cosine of 7 pi over 2? So what about the arc cosine of the cosine of 7 pi over 2? Well, you would think again you're going to just get 7 pi over 2, but 7 pi over 2 is out of the domain of the arc cosine, out of the range of it, I should say. It's out of the range of it. So what's a reference angle for 7 pi over 2? If we subtract 2 pi, this would give you the arc cosine of the cosine of 3 pi over 2. If you subtract 2 pi, that is. Well, you're still out of the range of the arc cosine, but here's the thing. What is the cosine of 3 pi over 2? That's going to be 0, right? The cosine of 3 pi over 2 is 0, so this will just turn into the arc cosine of 0. Now, what angle produces a cosine of 0 within the range of the arc cosine function? The range being from 0 to pi, definitely going to be pi over 2, right? So the answer to this is actually going to be pi over 2. So sometimes you actually have to know your reference angles and know your domains of your inverse functions in order to solve these. All right. We have the tangent inverse of the tangent of 11 pi over 6. Tangent inverse of the tangent of 11 pi over 6. Well, okay. It would look like we're going to get 11 pi over 6, but here's the thing. That's out of the range of the tangent function, right? Yeah, that's out of the range of it. Of the tangent inverse, rather. What is the range of the tangent inverse? It's from -pi over 2 non-inclusive to pi over 2 non-inclusive. If we subtract 2 pi from 11 pi over 6, what we should get is the tangent inverse of the tangent of negative pi over 6. Now, negative pi over 6 is well within the range of the tangent inverse, so what we really should get is negative pi over 6 for our answer. We should end up getting negative pi over 6 for that answer. Alright, so now we're going to take the sine inverse of the sine of 7 pi over 4. Well, the answer is not going to be 7 pi over 4 because that's out of the range of the sine inverse function, right? The range of your sine inverse function is negative pi over 2 inclusive to pi over 2 inclusive. But 7 pi over 4 is in the fourth quadrant, right? So if we subtract 2 pi from 7 pi over 4, what this should turn into is the inverse sine of the sine of negative pi over 4. That would put you in the exact same quadrant and within the range of the sine inverse function. So now you should just end up getting negative pi over 4 for the answer. So you'll end up getting negative pi over 4. All right. Got two more simple ones, then we change again. Alright, so we have the sine inverse of the sine of 5 pi over 2. Well, 5 pi over 2 is out of the range of the sine inverse function, right? What is the range of the sine inverse function? That's going to end up being negative pi over 2 inclusive to pi over 2 inclusive. Well, notice if we subtract 2 pi from that, 5 pi over 2, we should end up getting the inverse sine of the sine of pi over 2, which is within the range of the inverse sine function, so what we really should get is pi over 2. So the answer to this would be pi over 2. And one more simple one, then we have a few different ones here. We have the cosine inverse of the cosine of 3 pi over 2. So we have the cosine inverse of the cosine of 3 pi over 2. Another way you can do this, and you could do this with any of them, is take the inside. What is the cosine of 3 pi over 2? Well, that's 0, right? So that's going to then end up giving you the cosine inverse of 0. Now, the range of the cosine inverse function is in fact 0 to pi. What gives you a cosine of 0? That's going to be pi over 2, right? So the answer you should get for this would be pi over 2. Alright, now I have a few different ones here. So we have the sine inverse of the tangent of 5 pi over 4. So we have the inverse sine of the tangent of 5 pi over 4. This is where these triangles are going to come into play. So what is the tangent of 5 pi over 4? That's a 45-degree angle in the third quadrant, right? Which means you'll get a positive tangent. That would end up giving you the sine inverse of what is the tangent of 5 pi over 4? that's going to end up being 1. So that gives you the inverse sine of 1. Now, what is the range of the sine inverse function? That's negative pi over 2 inclusive to pi over 2 inclusive. And the sine inverse of 1 in this case would be positive pi over 2. So the answer to this would in fact be pi over 2. Alright, the cosine inverse of the tangent of 3 pi over 4. So we have the inverse cosine of the tangent of 3 pi over 4. Well, take what's inside. The tangent of 3 pi over 4, well, this is in the second quadrant, so you'll get a negative tangent. So that's a negative tangent of 45 degrees. That's actually going to give you a inverse cosine of negative 1. Now, what is the range of your inverse cosine function? That's from 0 to pi. Well, the cosine inverse of negative 1 would be pi. So the answer you should get for this would in fact be pi. Alright, so now we need to take the tangent of the arc sine of 0. So we're going to take the tangent of the arc sine of 0. Well, what is the arc sine of 0? That's just 0, right? That would equal the tangent of 0, which just so happens to be 0. So in this case, we should just get 0. So that one wasn't super terrible. That wasn't bad at all. Now, what about cosine of the arc tangent of negative 1? So we're going to take the cosine of the arc tangent of negative 1. So what is the range of the arc tangent function? That's going to be from negative pi over 2 non-inclusive to pi over 2 non-inclusive. Well, if it's an arc tangent of a negative number, we're going to be in the fourth quadrant. So you would end up then getting negative pi over 4 if you're going to have an arc tangent of negative 1. So this will turn into the cosine of negative pi over 4, which what is the cosine of negative pi over 4? That'd be negative of the square root of 2 over 2. So the answer you should get would be negative of the square root of 2 over 2. Alright, let's see. Sine of the arc tangent of 1. So we're going to take sine of the arc tangent of 1. What angle gives us a tangent of 1 within the range of the arc tangent? That's going to be pi over 4, right? So this would just turn into the sine of pi over 4, which we know would be the square root of 2 over 2. So the answer we should get would be the square root of 2 over 2. I got 3 more. Now how about this one? Sine of the arc tangent of negative 1. So we're going to do sine of the arc tangent of negative 1. Well, what's the range of the arc tangent function? That's going to be negative pi over 2 non-inclusive to pi over 2 non-inclusive. So arctangent of -1, that's negative pi over 4, right? So this would become the sine of negative pi over 4, which is a 45-degree angle. So that would be the square root of 2 over 2. And if you negate that, you would get negative of the square root of 2 over 2 for your answer. So you get negative square root of 2 over 2 for that answer. And I got two more. All right. Arcsine of the cosine of negative pi over 6. So arcsine of the cosine of negative pi over 6. Well, negative pi over 6 is in the fourth quadrant, right? Which means your cosine's still positive, which is the cosine of a 30-degree angle. So this is going to end up then being the arcsine of 30 degrees, or sorry, the arcsine of the square root of 3 over 2. So now we have the arcsine of the square root of 3 over 2. What is our range of the arcsine? That's negative pi over 2 inclusive to pi over 2 inclusive. So what gives us a sine of the square root of 3 over 2? That's going to be 60 degrees or pi over 3. So the answer we should get for this would be pi over 3. And I got just one more and we're done with the lesson. Arc cosine of the sine of negative pi over 6. So we're going to have arc cosine of the sine of negative pi over 6. So negative pi over 6 lies in the fourth quadrant. Well, pi over 6 is 30 degrees, but negative 30 degrees, so that would give you negative 1/2. So we're going to take then the arc cosine of negative 1/2. Alright, so now what is your range of the arc cosine function? That's from 0 to pi, right? Which means if we have a negative value for the cosine, that's going to be in the second quadrant, isn't it? Since that's in our range. Well, that would end up being, it's going to be a reference angle of 60, which would be a pi over 3. If it's in the second quadrant, you should end up getting 2 pi over 3. So the answer you should get for this would end up being 2 pi over 3. So that's it for this lesson. Next lesson, we're going to evaluate the composition of trig functions. We won't have as straightforward of angles like this. So we'll show you what to do with that at that time. I hope everyone has a great night. Take care.